All right, guys. I hope all of you can hear me well. Are we good? Jagadish, Navatej, Akshay, Ajit, a lot of our students. Guys, can you all hear me well?
I can hear you well.
All right, great. I think if you can hear me well, you others should be good. Right? Everybody, we are good. All right. So I think we're good to go. And as we proceed, I'm sure a lot of people are trying to log in now. So we'll have a lot more people in another 5-10 minutes, right? So in the meantime, we can get started, and we can help students understand a lot of stuff, right? Okay. Just one sec. What's wrong now? Are you guys able to see my screen? No, right?
No.
No. Okay. Okay. Fair enough. That's all right. Some reason it's not working. Okay. No. Okay. So probably some issue that it's not working. Any which ways, I think we good. At least we have started the recording, so we're good on that part. Okay. So let me get started, guys. Most of you would know me, right? My name is Kush. And I'm here with yet another session on data talks, right? Today again we have a very eminent personality. We have somebody who has worked in the industry for quite some time, right? And primarily we have Roopam with us, right? And Roopam has been there, working in the data science industry for almost 10-12 years, right? So currently he's working as the data science and predictive analytics a lead there at World Bank. He's working with International Finance Corporation. Prior to this, he has worked with Central Corp as well, right? Central Technologies, and there at Central, he was heading the data science and analytics practice, right? He was basically the center of excellence practice for data science. He was heading that. So and he had a lot of experience, right? He kind of did his MSc from IIT Bombay, and then tried his hand at PhD from Florida, University of Central Florida. I mean, did a lot of things, right? So he's been working in this field for quite some time. Somebody who has lots and lots of experience and understands data science pretty well. So I'm sure he's going to help you out with lots and lots of questions that you might have. Plus, the session that we have today is more of a podcast kind of thing. We might not share our screen. Here we'll be talking about a lot of different things that you might have. I'll kind of moderate the session and ask a lot of different questions from Roopam, and then in that discussion, hopefully you'll all get a chance to learn a lot of different things, right? So Roopam, let's quickly get started. Probably you can just introduce yourself, tell us a bit about yourself, and where you come from, what kind of other things that you can carry through. Okay, before I kind of talk about other things, I just want to point out to everyone that Roopam is also a very avid blogger, right? He has a very good blog named UC Analytics. He's the founder of that company as well. And apart from being somebody who's very technical, who understands the technical domain so well, it's very heartening to know that he is very creative as well, right? He kind of he tells you the blogs in the form of stories. You go and read those blogs, right? It's pretty amazing blogs. And then apart from that, he kind of adds this art flavor to it as well, right? So Roopam, that's also something I would really want to understand. So how did that come about? So because I mean, very few people would be able to really take an art and put it into a very technical world, right? You're somebody who's pretty good at it. Really amazed with that. So that's something I really appreciate. So just tell us a bit about you, and then we can get going on that.
Okay, sure. So mostly, actually, you told most of the things that I can talk about myself. But overall, just to give you a flavor of the kind of work that I'm doing. So primarily, when I started my career, it was in banking, and banking was the first industry that started with most use cases in data science, and that's like almost 17, 18 years ago. At that point, credit scoring was quite popular. Credit scoring essentially is like when a borrower comes to you, the idea is to score that borrower, whether that borrower is going to pay the EMI or the installments on time. And essentially, it's a probability of default which is converted into a score. So that's what credit score is. And I'm kind of sure that like most of you have heard about CIBIL, Experience, Equifax. Those are the credit bureaus. But these credit scores are internal credit scores, so it's beyond just CIBIL and TransUnion. Then, after working in the risk domain, I've also worked in marketing for banks, where the idea was to identify customer prospects in terms of whether they're going to buy the next product from the bank. And banking, if you see like product-wise, they're products such as liability products, where you have deposits, current accounts, FDs, and then there is an asset side of the book, which is essentially loans of various natures, and then there are investments where like insurance and other mutual funds. So this entire umbrella of product idea is to looking at somebody's behavior and telling them that this person is most likely to take general insurance, a car insurance or a motor insurance or a car loan or a personal loan. So those kind of things. In banking, the good thing that happened with my career, since it was the early initial days of data science, so I get to do a lot of creative bit in different industries, so not just in banking. Around the same time, I got to work with the healthcare industry in terms of identifying somebody's so in the US they have these EMRs and electronic medical records, where using that the idea is to predict which say patient, not exactly patient, but which individual has the chances of developing say a diabetes or any of those high cost diseases, and accordingly you help them out in terms of preventing those diseases. Then I've also worked in smart cities, these sensors, so the idea was to optimize parking and traffic and all those things using these magnetometer based sensors. So these are like IoT, which you keep hearing about. These are time series data on a recurring basis. Time series signals are being some magnetic fields are being your server is receiving that and analyzing that data to identify what's happening with the overall parking situation and traffic and those kind of things. Then I also worked with like images. This is a new wave. So when I started my career at that point, if you see images and text, for instance, were out of box.
Correct.
You have no way to use that or those kind of data in your analysis. And this is I'm talking about like early 2000, mid 2000, that period, even till like end of 2000, like 2012, 2010, like that was kind of not part of something that you use often, and even if you use it, it's like not very highly predictive in terms of the way you do your analysis. That all changed recently with all the deep learning and everything. Now, image and text is also part of your models. Image and text, if you purely per se, whether you use them just deep learning model, are usually input to the next model, because business use cases, if few of them will involve just text and just images. So most business use cases are beyond that, whether you talk about banking, whether you talk about retail or any other industry that I could think of. Some use cases do have like just purely images, but usually you take it to the next level, and that's where all the fun is happening. So that's essentially what it is. I've got the opportunity to work in various industries, and you asked about the creative part. So that's something which is always part of the way I used to do things as a kid, and then like because of the blog and because of the way things happen, like I thought like also used to use that side of my personality, and I'm glad that you are enjoying it.
Correct, correct. Okay, great. So very interesting things that you talked about. So one thing I just want to talk, add to that. So I mean, since 2011 and 12, right, when the deep learning became a little more popular, right? So 2011 when the real thing came up in terms of deep learning, and then this image and text and other things really flowed in. So prior to that, it was really not much was happening in that space, as very clearly pointed out by you. So okay, so we'll just understand bit from you. So when you said in early 2000s and in 2007, 2008, even in that time frame, we hardly had any area or anything from where we could learn, right? There wasn't any place from where we could really learn. So I mean, in today's world, we have a lot of MOOCs available, a lot of books are available. Everybody knows that there is Python, there's R, there's machine learning, there's deep learning, right? So those words are buzzwords, and everybody knows about it. So when you started back then, right? How was the scenario? How did you kind of decide that this is what you really want to do, and how did you get started with the learning phase of that?
Well, that's a good question. So at that time, these MOOCs and the online presence of machine learning, deep learning, data science was not there for sure. What was available were these books, but these books are also like any other textbooks, like that one could think of. So I think around that period, what was happening is like I was picking up a lot of books for sure, and that helped me a lot. So these are all very highly technical and highly like mathematics oriented books, because then you also kind of need to write your program to execute those ideas. Unlike today, when most of the packages are available for R and Python, as you mentioned. So that, if you ask me, helped me a lot. Like what's happening is that though the MOOCs and so much information is available, which is good in many sense, and there are like certain drawbacks to that as well. So the like what I experienced at that point is because the idea was to learn so many different things, and
okay, sorry, you're not audible, Roopam.
Part of the people who were doing data at that point.
I'm sorry to interrupt you. I think for the last 30 seconds you were not there. So if you could just repeat from, you said that you picked up few books and they were pretty interesting. Okay. So I think we lost connection there. Anyways, we can go ahead.
Okay, after that. Okay. So I was telling you, like I picked up books was the primary source of learning, not the MOOCs and other channels. These days you have a lot of these websites and blogs and places where you can go and see what's happening. So that's very exciting. That I feel has added a whole new angle to learning, and which is always good. But at the same time, what I was saying is that since like when I started, there were fewer sources, so it also kind of cut down on the noise. We were learning from things and that were very grounded and very very application based. However, like in those days, if you see, like the whole use cases in data science have also started becoming much more complicated. So in the early days, it was also about people learning the field, people learning how they can use it. So initial use cases were fairly, I would say, version 1 use cases. These days, as I was telling you, like there are so many cool ideas that are coming in where you can use. So it's no longer about like learning the programming language anymore. It's no longer about learning a technique, but mostly about how you are going to use it to solve a business problem. In those days, like there was still like a level of like people who used to know a little bit more than others were valued a lot. So getting a job was relatively easy, if I say. But these days, if you see, like everybody knows Python, everybody knows R. So then there's a whole additional layer of thing that you look for in a professional when you hire them. So that's the another side of data science which is emerging, which is also exciting and also like little bit like is asking more from its professional than what it used to be in those days.
So pretty interesting, sir. So I think the key takeaways primarily here would be that programming now is not that important, right? Because we have a lot of packages inbuilt, and people can really use those inbuilt packages to take this stuff forward and easily work with data. But yeah, but we certainly believe that there are a lot more lot of noise in there, a lot of chaos in there, which is really which kind of makes it difficult for students to kind of know what to learn and to what depth they really need to learn things, because there are a lot of jargons which are floating around, and most of the people out there, I mean the kind of interaction I have with a lot of students, I see there's lots of confusions in the term. So everybody gets just stuck with the term data scientist, they get stuck with the term data mining, they don't really know what it is. But somebody has said data mining, so I also need to do it, but what it is I don't know. So those kind of things are still very prevalent out there, right? Okay, so fair enough. So we'll just take it forward from there. So okay, so you kind of stressed on one point that back then when you started, it was simpler in terms of books and very technical stuff, right? So probably the hiring also happened in that respect, right? So people were expected to be very, very technical, and somebody who's very good with deep into mathematics and statistics, PhD kind of people. Probably those kind of people were really preferred back then. Vis-a-vis today, right? Today it would be a very different scenario.
So I would say very different scenario, drastically different. It is different because what I experience is that people kind of focus a lot on these programming languages, and they are like calculators. So you need to know your calculator for sure. But the problem that you're trying to solve using that calculator is what a hiring manager usually look for. And that's what the whole emphasis is on of late. Initially, like because it was very new, and then whoever was kind of prepared to do those kind of things was relatively easy to get into the industry. But lately, what's happening is there are a lot of CVs available in the market, and that's where expectations are also much
different. Okay. Fair enough. Yeah, so Chandan, you're not sharing your screen, just to let you know, what made you change your domain from banking to IT and data? So it's not really change the domain, just an addition of the domain. So okay. So Roopam, probably we would want to move into another aspect. So when you talk of the BFSI space, right, where you have been for so long, and how have you, you pointed to it to a certain extent that earlier what we were doing was the version 1 cases, which were pretty vanilla use cases, and trying to understand the credit risk modeling, and trying to figure out people, and very basic use cases that okay, whether somebody has the credibility or not, or should the loan be given to those people or not, and some other insurance based use cases, right? From there on to what we see today, right? What kind of current trends do we have in this particular space in BFSI? What kind of use cases are kind of coming up? If you can just elaborate a bit of one or two use case of now, and then how do you see it going forward, right? So from now on, what kind of expectations should individuals have in that space?
So if you see the use cases that you talked about, they were relevant 20 years ago, and they are still relevant, because banking industry, if you see, primarily the idea is that whether you are be able to evaluate somebody's risk at a higher degree of accuracy, and also whether you can identify opportunity to grow your wallet share, and then how to expand your product. Because if you see, acquiring a new customer is always much more expensive than expanding your current base of customer and selling them more products. So the problem statements, if you see, are still relevant. So it's not that pure vanilla when we say it means that those were not important questions. Those questions were important then, they are important now, and they'll continue to stay important.
Because that's the bottom line.
Yes,
Sorry.
that's the bottom
Yeah.
line.
So I mean, and that's how the business
Wherever you're
functions,
growing the
especially for banks.
revenue, wherever you're creating an impact on bank's P&L, those statements will continue to stay relevant.
Correct.
And what is happening is that new use cases are being added on top of that, which is again impacting the P&L. So that's how I'll put it. The emphasis will always be on how are you going to help the company or a bank or an organization improve their current businesses and financials essentially. So everything is linked to financials, and that as a data scientist is very important to know, because then you can craft your solutions accordingly. The second part is whether it is something that is what are the new use cases. The industry is also kind of different than what it used to be. So initially, if you see, credit scoring was primarily for retail, and that too for salaried clients. In the beginning, that's where you have information. Of late, the industry, as you have already seen, that like there are a lot of these large corporate defaults, and that's where a new segment, which is a large, huge segment, is much more relevant. So, like say MSME, SME lending, that's also important. Understanding your MSME flow. And that's where the knowledge is fairly low at this point in the industry. Like, I mean, though you know your salary price very well, fairly well, I would say. And salary can also be a very off late, like the way kind of stress that the economy is experiencing. That segment may also experience some level of stress. Let's see how things will pan out. But the other segment, which is also very relevant, is your MSME, SME, and mid corporate, where you can use data science to produce much better results. And that's a growth area which, if you see, the banks have started investing a lot of their interest in these areas. So that's one thing which is again the same. It's not that the idea is completely different, but segment is very different, and the kind of data required and the way you do the analyze that segment is very different. So that's one area of growth for both. And the fintechs are all coming in. So fintechs, what's happening is that lending is happening through not just your traditional app-based, application-based platform where you need to write a whole application and then PD and all that. New sources of data are being introduced. So whether it is coming from third-party sources like Snapdeal or all these third-party sources are available. If you can make a tie-up, then you can identify ways to lend to these sellers who are on the platform. So that's an MSME area. So the complexity of data is growing. Use cases, again, going to stay the same for all, industries, where you have to create an impact on P&L. And there's no way out of that. You can find new ways to create an impact. But at the end of the day, the value of data science is still judged the same way, whether you are creating an impact on the P&L.
Okay, fair enough. So I think that will happen across the board for any industry that we take, right? So at the end of the day, what kind of efficiency improvement we are able to bring to the business, that is what will be the driving factor in terms of adoption of data science and predictive analytics. Right.
That's correct.
So yes. So just elaborating your point there, you said that we primarily working with a lot of structured data when it comes to the banking domain, right? The use cases that we've talked about majorly focus on the structured data. Any kind of
not really. So structured and unstructured is also being introduced now to a larger extent. The text, when you look at bank statements and various other sources that are not like your traditional RDBMS kind of structure, but outside that, and which is happening in every industry.
Okay, no, that I agree. So my precise question was that when you talk about the banking domain per se or BFSI domain per se, do we have any use case that you can talk about, which kind of requires a lot of image-based analysis, image-based, some application that you might have come across?
So image is a difficult problem, in any use case. So though, like, I mean, mostly the work that is happening in image world is again a very structured image. Like, I mean, images are being tagged as what they are, and basis that all these calls are taken. And the second thing is the whole idea of standardizing the images, because you can't just go and click any old random image like all around. And so I'll give you one example. Say, and which is an interesting use case. However, like how to work on it is not such a trivial task. Where let's say, like, I mean, I'm coming back to the MSME world. If I am talking about mom and pop shops where like you go and you look at their condition of their shops. At that point, if you take some images and if you can figure out what is the state of that shop from that. So essentially image will get converted into some information which says, okay, this is, yes. And that eventually could become part of your, the models that I was talking about to make your models better. So again, image on its own will not have a value, but information generated from images will become part of your larger model, which will have structured, unstructured, and all sort of information going in. So that's an interesting use case. That is one thing which, and many such use cases can be thought about. The challenge is that, first of all, image information is available, but then standardizing them and kind of tagging them into just looking at somebody's, which has to be kind of standardized. Like, because if you see image, one of the use cases which like one of my somebody used to work with me, he's working on is on these say cars. So they take an image of a car and try to assess what is the overall damage in that car. But these images are taken in a very standardized environment where it's a garage where like things are placed in a, cameras are placed in a much regular form, which may not be the case when people are wandering around in fields. How to create that level of standardization is a challenge. So not unstructured and unstandardized images is where still a lot of work is required.
All right, great. So, there are a lot of questions coming in from the participants regarding their career transition. So just guys, hold on to that for some time. Probably we'll come to that in another 5, 10, 15 minutes. And we'll talk about your career transitions, right? How you can get there, what kind of things you should learn, whether you can really get in there or not. So just hold on to that. We'll come back to that in some time. Okay, great. So I mean, this is a very important takeaway for anyone, right? That the standard, I mean, when we talk about image analysis, most of the time we kind of, take it that there's a standard image which is available, right? Which is something which is not true, right? So,
sorry, I missed you. For
yeah. So
10 seconds, I lost you. So if you can just start it.
Okay. Yeah. So I was primarily telling everybody who's on the call, right, the other participants, that the takeaway that they should have from this piece should be that standardization of the image is something which is not really, coming up very strongly. So that is one area. If you can develop something in that area, that could be really, really exciting. So all right, great. So yes. So okay. So and you talked about couple of more use cases. You said you work with smart cities. You work with the healthcare domain per se. So I know if you can elaborate a bit on the smart city one, that was something a little exciting to me. But if you can elaborate a little more on that, if you believe.
So just one use case from smart cities I'll give you. There are many different nature of things that are happening in that area, but just one example, just to keep it short and simple, is about parking. So parking is a major problem for all the major cities. I mean, if you've ever lived in a large city, say Bombay or New York or any such city, like parking your car is a big problem, because finding a space to park your car is a big problem, not just parking. So that's where, like, I mean, this thing that I was working on was an app, which essentially, if you're driving around, think of it like an Uber, where you can say, okay, this is where I need to park. Like, you just do that, and then it will tell you, okay, you know what, like these are the 3 parking spaces that are available. 2 of them are paid parking, 1 of them is free parking, whatever, like charges that are there. and then you can immediately put that space, and then you can go and park there. Now this is all happening automatically. I mean, there's no, unlike in India where you have somebody who is assisting you with this parking. In a mall, like you have this whole staff which is helping you. Even in BMC parking in Bombay, especially, you have people who will come and give you a slip and say, okay, this is where the parking is, and you go and park there. So things are all assisted by humans. This one is a completely automated system. There's nobody who's looking after like the parking spaces or any such. So how do you know that a parking space is vacant or not? There are many solutions that are being proposed for that, but accuracy of those solutions is not like all those solutions are not as high, because if you're talking about, okay, you go and park there, and if you go there and there's already a car there, you're losing a customer, and there's a lot of things that will happen. Nobody will use that.
Correct.
So here you're looking for almost 100% accuracy, nothing short of that. And that's where these sensors. So what was done is these sensors were installed in all these spaces where parking lots, and they are sending just the magnetic field of that space.
Okay.
And as you will understand that in real world environment, unlike a lab environment where things are all controlled, real world environment has lot of things happening which are magnetic in nature. So for instance, you've got a electric wire going close by, which is a AC wire, so it will just create a different kind of signals. Then you have like, if anything of electricity is magnetism, it's like physics 101, and that kind of noise is built in virtually every of these sensors, and they just behave in a very different. So you are getting a lot of noisy data, a time series data. So think of it like XYZ coordinate of your magnetic field. 3 vectors is what you're getting, and plus more information. And using that information, the idea is to say, okay, like I'm 100% sure that there's a car that has just parked, or a truck that has just parked
that
2 seconds away. Yes. And that the space is occupied right now, and it will be vacant after a while. This use case can be extended for a much larger thing. Like, I mean, think of a mall where you have people who are using these apps. They're also letting you know about who they are and what they do, like, because they are feeding this information. So using that information, you can also figure out who is the customer you want to kind of place it near the market. So that could be a marketing opportunity as well. And then a lot of things can be built around the same use case.
Correct. So yeah, so once you have an app around it, then a lot of things certainly can come around that. Very, very true. Correct.
Yes. And that level of creativity is what is expected out of data science these days, or data scientists these days, rather than just somebody who can do a Python coding and like put a program.
Okay. So
and like
sorry to interrupt you. Probably so then probably we'll move to this part only, that when, as per you, right, if kind of let be a little elaborate. What do you think would be the expectation from somebody who's trying to go into data science? So one part you were saying that, maybe apart from that, just a little elaborate on this one.
Somebody who's, sorry if you can come again on that.
Okay.
Somebody who's trying to get into data science. Is that
somebody who's trying to become a data scientist. So what does the industry expect, right, from that person in terms of skill sets, in terms of his knowledge and other stuff?
So skill sets will be very different expectations from different professionals. First thing that I like to say is that data scientist, though it is presented like one person, it's usually a team. It's not one person, and each person in that team has a different kind of responsibility and different kind of roles. And that's why I find the field is so exciting, because one can't just say, okay, like when I want to be a data scientist, I need to do mathematics, or I need to do this kind of thing. It offers such a large spectrum of opportunity for its professional. For instance, if you are a more tech-driven, so you want to work with data, then the data management is a very cool subject for that profile. Then if you are like more visual, if you like artistic part to your personality, then the whole visualization, which is also very, very important. Because what's happening is people are just churning out dashboards, but those dashboards are never used by people. So if you want to be in that space, it's also very exciting. Third space is solving business problem and essentially like gathering business requirement. That's another area, business analyst. Uh, then uh, then there comes the part where you have these skills with Python and uh, R and whatever other languages, machine learning, and so then you solve business problems and be a BA as well. So a lot of opportunity for its professional. The important part is one has to figure out what is the part that excites you. So don't just get swayed by what's happening in the world. Like when everybody's saying this is what data science is, you can actually create a space for yourself based on your personality, and that's when you will be successful. That's how I feel. Because at the end of the day, just because it's cool does not mean that it's for you. Just ask yourself what part of it excites you, and then choose a career accordingly. The second part is like when somebody is trying to make a transition. I'll define that category into two pieces. One is a fresher, somebody who is just freshly graduated from a college, trying to get into data science. The second kind of professionals are people who have worked in other domains. So say you are an IT professional or a banker or worked in Amazon or whatever, but not in the data field. Now you are trying to make a transition. So these are the two kind of transitions to data science you will see. For the first kind of transition, let me talk about the people who are experienced, who've got some years of experience, and now they are trying to make a transition. So at that point, I hear a lot from these professionals that they have to change their job or they have to switch their job, which I think is good if it is possible, but it's not the most optimal way to look at things. Because whatever job that you are doing, you have gained some experience. If you kind of make a transition on top of that experience to data science, that will help give you that additional boost. So a professional, say, who has worked in accounting for last 10 years, if there's a lot of things that you can use data science to enrich their own current field of work. If you just may, okay, I'm going to start all over again as an intern after 10 years of career, may not be a very good idea. So the idea is whatever you have learned and whatever you have mastered in your 10, 15, whatever years of career, and I see a lot of these professionals which I come across. So I ask them to kind of build data skills on top of their existing skills, and which is what is required in the market as well, because at some point you will see everybody will be data scientists. Then because so much data is there, if you go to a boardroom of any company, and I've been to some, nobody is talking in terms of just anecdotes. They want to see numbers, they want to see data. In every meeting you will find that, and those are the companies who are doing good. So eventually what you'll find is everybody required to have this skill. The second class of people is who are just freshly graduated from college and now trying to get into data science. At that point, where to start is the question. And I would say at that point, people put a lot of emphasis on keep doing projects. There's nothing like getting a real exposure, working with a team. So work in a place where you are part of a large team. That's the best strategy for somebody who's starting fresh, where you have established professionals who are already doing it for a while. So I think no matter how many Kaggle challenges you take or similar kind of things you do online, you're never prepared for data science as a profession, because it's very different in there. Once you get into the environment, it's a very different environment than solving just Kaggle challenges, which are very well structured. Everything is done for you. Most of the time you start with what is the problem to begin with, and what all information is available, how to kind of create relevant variables. So those are the kind of challenges that are there, which kind of build your career. So I would say a good strategy for such early starters is to kind of work in a team and then grow from there.
Yep. All right. So okay. So I'll just add to this. So I mean, the way we kind of talk about it also is that whatever you're doing, just take it as A plus B. Don't try and sell yourself as a data scientist. That's not going to work out. And because in any case, right, you have spent certain amount of time doing something in the industry, and why do you want to let it go? I mean, I know that somebody might have just worked on a support project, but then there also you have gained some skill, right? Whether it is talking to clients, having maturity to really deal with businesses, deal with a team, and so on and so forth. So there can be, apart from that, the domain that you work with, right? So if you can just take that particular domain and kind of take it forward towards data science or add data science to it, that's where a lot of value addition can be, right?
No, absolutely.
Although
never let go of your experience because that's very hard to achieve. Like, I mean, if you have spent some years on building one skill, think of data science as an add-on to that skill. Not like, okay, complete transition.
Yes. Also, I just wanted to understand from you. You said that for freshers, a Kaggle problem would not help. So, I mean, probably for a pretty large, experienced personnel who is getting in there, who already understands, stuff about things, how it works in a team. For them, I know it will be, it will not really help, to that great an extent. But if somebody who's starting into data science, who's fresh out of college, who's just trying to know and see certain problems, so probably, to get their hands dirty and to get their whatever skills they have in terms of, say, R or Python or machine learning or other things, they can at least validate, or in fact, everybody can at least validate those skills when they Kaggle then they kind of, solve these Kaggle problems. So, I mean, what's your take on that? Do you think that really happens, or even that is not the case?
No, so certainly the case. Like, something is better than nothing. So the way your interviews will go, so I'll give you some common patterns in most of the interviews that you will take, because I've got a lot of friends and colleagues in the field, and how we conduct our interviews. I can give you a feel for that. So there, the questions are going to be mostly around the project. So what have you done? If you can just run me through one of the projects that you did end to end, and be open to jump to the whiteboard at that point and just explain it thoroughly from end to end. So that's one of the things. If you are already in a company, then you will be able to explain that project like that. Second is, if you don't have that experience, Kaggle is still a very good platform to kind of showcase what you can do with data. So pick a problem which is much more complicated, where many data sets are given to you. So not just like one flat file and you just do your modeling. Also pick problems where there are real world variables are given. Kaggle, if you go to
sorry, Roopam, we are losing you.
Are you there? Hello?
Yeah. I think we lost you for some time. Yeah. Can you come again?
Okay.
So you were saying that Kaggle. Okay. Yeah. So about 10 seconds back, when you said that you need to take multiple files and data sets which are not just flat files. So I think that's where we were.
Okay. So it's first take multiple files, because that's real world environment as much as possible, where you are doing your joining and trying to create new variables. Second is take problems where they have given the actual variable names, where they're explaining, okay, this is what the variable is, and the names are given. It's not just x1, x2, x3 variable name and y is the output, and just make some model. So I recommend you pick problems that are as close to real world as possible, because then you will be able to explain that problem in depth for if an interview is typically a 1 hour around that time, and then you can take about 30-35 minutes if you can explain that problem end to end, and then the person can ask questions around that. That will definitely boost your chances of getting a job.
Okay, great. So just to add here, I think if you can take problems, somebody who's kind of experienced, if you take those problems which are closer to the industry that you are working with, I think that will also, add more flavor to it, and then you would know a bit more about the domain, so you will be able to explore a little more on the problem, right? So that is something which will also be very, very helpful, right? And
so don't be open to everything in the beginning when you're starting your career. Don't do everything. Kind of focus on one or two industries that you want to focus on, and then even on Kaggle you build your portfolio like that. So it's not that you do everything, because because think of a hiring manager who is working, say, in a manufacturing domain, and you're talking to them about a completely different domain, say e-commerce. It's hard for you to create that rapport with them during the interview, because you're going to talk of terms which are not so familiar to them. So that's why say that these are the two industries that I'm going to target. It's finding a job is also a very structured activity. It's not like unstructured. You go for every interview and you just show up. I think it's also a very well planned activity. Okay, these are the two or one thing that I'm going to work on. These are the kind of jobs that I'm going to apply to, and this is how I'm going to take those interviews. You also anticipate the kind of questions that will come. There's a lot of information online, but also you need to figure out whenever you go to an interview, try to write down that these are the questions that were asked, where you did well, where you did not do well. So being a very that interview awareness is absolutely important, because a lot of times what I see is, like, when people come for interview, they sit for that 1 hour, they'll go out. When you ask them how did you do, they have got no idea how they did, because they were so consumed and so focused on just saying things that they were not actually listening to themselves. They were not listening to the interviewer. So that awareness is one of the key things, and that stays true for every interview, and data science, of course, it's true.
Mm-hmm. So I think that stays kind of across life, right? So you need to be aware of what you're doing. Most of us are not, right? So most of the activities happen, autonomous, right? We are into that autonomous mode. Things just keep happening. So that is again a very good advice, I would say. In not just take it from data science perspective, take it from a life perspective also. That is something which really can change your overall persona, right? So that is something, being aware of yourself, what you're talking, how you're talking, how you're going about
being
anything.
Aware of yourself and being around your,
yes.
More than that, being aware of your surrounding, because you're aware of yourself. You're listening. Everybody likes to listen to their own voice. So the part is whether you are aware of what's happening around you.
Correct. Fair enough. Very, very interesting thought there. So, all right, okay. So when you, let's kind of go a little deeper into this. So when somebody is trying to learn it, right? So kind of he says, okay, I'm learning this particular technology, and the technical skills I've kind of learned. So how would you approach, or how would you kind of say that, okay, how should somebody learn, have this approach towards learning data science? So what would be your suggestion in that respect?
What is my suggestion in terms of, sorry, I didn't get the questions.
Okay, so the question is, when somebody is trying to learn data science, trying to get into that field, so obviously he or she needs to, maybe you're coming from a very different domain, right? You have no idea of even how the data handling is done. So when somebody is starting out, right? So apart from the the projects part, which obviously will be secondary, the interview preparation, as you said, all come secondary, right? Maybe another important thing that people can add is the productization of the model, right? If you can kind of have a web application or something which kind of shows how your product really works, or something that you can create, which will not just have the data science or just the machine learning and the data handling skills. It would also kind of you might use your integration skills. You might use some skills which can kind of help you create an end-to-end product. So will that be something that will be really appreciated, or how does the industry look into if somebody does things of that sort? So that's one part of it. And the second question, primarily the question was something, kind of just product development part of it. And before that, probably how should somebody start learning? What should be the way to learn? Because I'm sure most of the people, again, your thought to that is how important is mentoring when you're learning a subject as good as data science, right? When you have complex things like deep learning and machine learning. So how important is mentoring out there? How important is is knowing which topic to learn, to what depth to be learned, to they need to learn, what really need to be practiced upon, and stuff, right? So what is your take on that?
So that's a good question, actually. Like, so I'll tell you from my own experience, like interviewing so many candidates, and I'll possibly put it from that perspective, and what kind of approach I've seen working for candidates, and what may not be a good approach as well. So I see a lot of times like people kind of go to a training institute and they just acquire because there's no certification as such, or there's no standardization. Since the field is so new, it's not that like I'm looking for a certificate as such, because there's no certificate that I can look, unlike CFA or risk management or various other fields that are available, which have evolved in a long, which has a long history, and that's why these certificates are also have a very high value in those fields. Unlike that, like data science is kind of similar to that in terms of amount of knowledge, or like it could be even more challenging in many sense. But the thing is that since the field is so new, and since it's evolving so fast, as I was telling you 5 years ago, like images started coming into, there's no one certificate. So people go to training institute and they think like, that's a certificate and I've got a certificate, so I could get a job. That will not happen, because like even the interviewer is not aware of any certificate. When people say, oh, I've done this in this college on this, it's as good as, okay, like, that's fine. So now let's talk, now let's get down to the business of understanding how much you know. So the interview, the way it will go is like, it's not that like, you're getting any boost to any of the certificates that you've got. The boost that you could get is like actually talking your knowledge, and that's where like maybe a mentorship program could be a useful program, because people who have done it for many years, and if they're kind of guiding you, this is what is expected in the industry. Before going for an interview, you're getting a feel of, okay, this is what people will ask me. This is what the kind of case studies that will be put in front of me. This is what the kind of questions that will come my way. And if you're already aware of them, you are much better off. So like, I was talking to like what could also happen is that like a lot of these training institutes, you will find that they are like the training is done not by the professionals. So they're like, because if somebody has like teaching you machine learning, statistics and all these things, without being in the industry, then they can give you a very good understanding of these topics, possibly, but not the feel of what goes inside the industry. So the mentorship program where like you're learning from industry experts is always something that I believe will help you, because that is where you can understand, or you can preempt what kind of things will happen in your interview.
Okay. And yeah, so okay, so in terms of knowledge gathering, that always has to happen. You cannot back out from that. But yeah, you should know what to learn, and obviously to what depth things have to be learned, right? And obviously industry experts.
It's not go for an interview. Whenever you go for an exam, you plan for it, you prepare for it. So same thing applies to an interview.
Correct. Okay. So I think that's another very, very profound statement, that you don't think it as a job change. Think it like you're looking for an interview and you want to crack it, right? So what all needs to happen needs to start at the very beginning. Your mindset has to be aligned to where you're going, and then you kind of reach the end goal. Great. Okay. Okay, this one quick question. So again, I think more or less, I believe I have the answer to that, but somebody's asking it here.
Yeah. Just quickly, like if I can interrupt, since we are getting at the end of the conversation, I think you may want to also look at the questions that.
Yeah. Correct. So I'm already looking at the question that. Correct. I'm coming to those questions. Yeah. So so this one question that people somebody asked me, right, that I want to quit my job and then start learning data science. Would you really recommend that, or do you think that that's something which should not be done?
So, like, I mean, if you can just kind of point me towards that question, I'll just answer to the person.
No, so I mean,
This is
yes,
it's not in the
yeah,
Q&A.
it's not here. Somebody asked me
Okay,
on
okay,
chat
okay.
window. Yeah,
Okay. So, who asked you this, the name of the person so that I can address to them?
yeah, just Akshay.
Akshay. Okay.
Yep.
So, Akshay, what you're asking is that, like, if the question, if you can just frame it.
Yeah. So basically, the
Could
question
you
is,
give Akshay the?
yeah, I think he would
Could we
not
ask
know. So
Akshay to? He will not be
probably,
able to. Okay, no
yeah, he'll
problem.
not be able to speak. Yeah. So the question is very
Okay.
serious. Is that should I quit my job and then try to learn data science, or should I
Ah,
continue and yeah? So that's the question.
no, absolutely continue with your job. Don't quit your job. Never. Think of it like, and this is what I was telling from the beginning, that I don't know what kind of job you're in, but let's assume that you are in some job where you have got acquired some skills and
Mhm.
you are constantly learning new things. And it could be a field which is completely different from data science. Don't let go of that knowledge, because then what you're doing is you're starting from scratch. Then you're putting yourself in the same domain as freshers. I know, like, I mean, a lot of times when you're working in a job, you kind of feel stuck. Okay, like, how will I kind of link this to data science, and how will I link this to data and do some analysis? Make your best effort of finding some way to use data in your current job. May not be possible all the time, and if it is absolutely not possible, if it is completely like not, but don't just give up on it from day one. Just try at least, if you can find some data related use cases. Talk to people who have got experience in data science. Talk to people who have got experience in your field and data science. So those kind of people you want to reach out to, and identify how you can improve your current job using data. And then you are actually on a track where you're not losing of your current knowledge, but you're building on top of that. And then industry will actually see you as a much like interesting prospect and interesting candidate. Then if you just start from scratch and you say, okay, I've done that, but I'm over it and now I want to start all over. So that's a cool part about data science, that it's applicable to so many fields. And that makes it like also interesting for a professional to find ways to improve their current work and kind of add a additional skill on top of what they already know.
All right. Okay. So I think Akshay, you got your answer, right? So okay. So there's a question. Hi sir, what made you get to change your domain from banking to IoT and data science? I think as very clearly mentioned, he's just adding on top of it, so he's not changed the domain. So I think yes. So we already discussed this one. One case of images on banking domain. So we already had one case about it. It's great motivation to hear from you, actually new to this field. Can you show me light where to start from, as it's very, very confusing? Okay, so Anirban has this question that, where should he really start when he wants to get started in data science?
Where should you start? And you are a fresher or a professional?
He's not mentioned that. Can someone get into this? Does it pay for someone not from this space to learn ML and DL? Okay. So which field? So let's take it from both the perspective, right? So maybe we'll get to understand that. So considering he's a professional and considering he's not, either ways.
Considering a professional, as I said, like, I mean, if you're a professional, try to find things which are related to your current profession, because that is an add-on. That is always like industry will view you as somebody they want to work with if you are doing that. If you are a fresher, then it's like the whole green field is in front of you. It's like a blue sky area. Then the first question that I would ask as a fresher, like, I mean, like, what are the things that I enjoy? Because when you're building a career, it's not just about getting a job which will be miserable after a few months. It's also about finding a job which you will enjoy. And within data science, I'm not saying like outside data science. So within data science, I have 5 fields. Actually, I'll enjoy the technology part. So I like the data engineering part, or I like the data management part. I like visualization, telling stories. Is that your skill? So this is something that like in India we don't do. We don't kind of introspect and kind of try to learn about ourselves. That self-awareness which we were talking about in the beginning. It's a good idea possibly at that point to say, okay, this is what I enjoy. And whenever you build your career on top of that, you'll always do good. That's how that's what I have experienced all throughout. I've done things which I enjoy. And it might be like, you say, okay, like I need to get a job immediately. Don't put yourself under such a tremendous stress and pressure, unless it's absolutely required. But if you have some level of freedom, I say spend it on learning about yourself. What are the things that you enjoy? And then even during an interview, you will come across as somebody who the other side of the spectrum, like an interviewer, will enjoy talking to. Because when somebody enjoys what they do, it comes across very easily in interview. And trust me, as an interviewer, those are the things that I look for. I don't look for like 100% answer. I don't look for concrete, like somebody has given it. If you ask a question, it's not an exam like a college exam where you ask something and you need to give the perfect answer. There's no perfect answer in real life. But you also look for this attitude, whether like this person is something who is like going to enjoy what we are going to offer to him. Is he somebody already bringing new thing to the table? Is he going to work well with my team? So those are the questions, and that personality comes out very clearly in interview, and that's what like an important thing.
Yeah, fair enough. I think that's answered pretty well. So I hope you got the answer. I think we are losing you. Are you there?
You're losing me?
Yeah. Now you're good. Okay. So I think I think that's answered pretty well, right? So just understand this. You need to know whether you are a square peg or a round peg, right? And you try and get into that hole. If you're a square peg, get into a round hole. You'll feel miserable all your life. So don't do that. You need to understand, whether you are a round peg or a square peg. I'm just telling you that. So I kind of keep telling this to everyone, but very difficult to it does take a bit of time for people to really follow that. So you iterating it probably would enhance that thought. All right, great. So does it pay more from this space to learn? Okay. How can someone get into data science space? Does it pay for someone not from this space to learn ML and DL, etc.? What is advice for people to learn ML from scratch? Should they at all try doing it? Yeah. So obviously, So I think we just answered that there's a lot of scope. Industry is there's a lot of future of data science across the board. Every organization is using it. We're kind of getting into that space where people will have more and more use cases. So this will certainly help you. If you enjoy doing it, then certainly you should get there, right? So if you I'm not sure how you would do it, but I think if you are somebody who's analytical, who likes to go down into numbers or your visualization and stuff, then you can certainly take up any of these, right? So it's more about interest. Don't look at the money itself. Money would automatically flow, right? That's the same thought, Roopam. Agree to that?
That's correct. That's correct.
All right, fair enough. And application development is moving towards cloud computing. As application development is moving towards cloud computing and microservices, do you see anything such transition happening in data science world? Service-based architecture is what he's saying. So I think you can take that up, and then probably my views. I'll just certainly iterate that. You see that question?
So, no, I did not see the question. How do I? So I think I'm seeing completely different questions than what.
Okay, no, I'm trying to go from the top. So probably 5th or 6th or 7th question from there.
What are people ML scratch? ML from scratch? Should they at all
just after that?
Okay. As application development is moving towards cloud computing, microservices. So like hard for me to say because I mean I'm not an expert on everything and I am first to admit it. Like so I don't know these like what exactly do you have in mind? But
Okay, let me take it. Let me take that. So, okay, see, when you what I understand is that he's talking about AI-based platforms, which are cloud-based platforms, which you already have now. You're saying when you talk about those platforms, um, will data science also move into that space where it's offered as a service? So
it's already being done. That's okay.
It's already being done there, right? Yeah. So that's already being correct.
I'm doing it like in various projects already. So it's not a new idea. It's being used on cloud and like those services are also already being used. Yeah.
Certainly, yeah, correct. And then there's a question that it's opening only for IIT and PhDs. I think that was long back.
Not really.
Now it's a very different world, right? Now you can kind of come in if you know what things said.
Mm-hmm.
All right. What is the scope for transition from infrastructure management to data scientist if I don't have any development experience? And so basically saying I don't have any programming experience. Although I have I don't want to get into programming a lot, but can I still become a data scientist and analyze data?
Then you can explore those business analyst kind of roles where you're trying to come up with business problems, like I mean where you are actually a consultant. So think of yourself like a consultant who can do some bit of data science. If you're not doing any data science at all, then like I mean you can't be. But think of yourself like a consultant who solves business problems and who also understands the other side of the world.
All right. So I'll just add to that. So when you say you want to become a data scientist, probably I think it would also mean that I mean you don't want to get into programming a lot because as a data scientist you don't have to code everything these days, right? You have a lot of pre-built code. You just use that to kind of do the task. So to a certain extent,
Google, like so I'll tell you, like I mean even when I code, every third or fourth line I had to go to Google. So it's not that I know all those codes. So it's not like
So I mean that's what we always say, that data science is not about programming. It's just the tool. It's an enabler to get you there. Right, and in today's world, when Google is there, everybody is kind of more or less similar. So it's content economy is more or less, and that's gone, right? I mean, Google has kind of played a significant part.
Sure.
So don't worry about that part now. Yep. So fair enough, but sometimes a complete transition is required for the persons who are working as tester or QA engineer. Again, Akshay, I think as he really said earlier, correct, we already answered that question. Right? Fair enough. So we're going to complete data science courses. Shall we go for deep learning, IoT, and AI also sustain industry? I think not right away, Lokesh. I think first you need to get yourself comfortable with what you are doing. Okay, and then probably maybe I mean your thoughts can also come into this, Roopam.
Yeah. So like actually like I mean it depends on what you like. I mean at the end of the day, like don't just run behind coolness. Do things which, if you see that there is utility for you to learn these things, go ahead. I mean, if you think it will help you get a job faster because you already know these things, go ahead. So don't think of it like, okay, everybody is doing it, so I should also do it. It's whether it will help you get to your desired goals. That's what it comes down to. So all the technology, everything is the same.
All right, fair enough. So personal, professional banking and lending domains. Okay, that's what he said. Anirvan was trying to tell us that. How do we highlight our CV when you are testing background with 10+ years experience? So that's a question from Sandeep. What should we be highlighting in our CVs?
So you are trying to get into you've got a testing background. Now, the question is, how can you enhance your current work with data science? That's what it comes down to. If you're looking for a job in data science, if you want to continue in testing, of course, like I can't tell you what. But if you want to get into data science, testing is another area where like a lot of things are happening. So whether you can automate these testing using machine learning, you are seeing this data all the time. So people are using in Amazon and other places, like I've spoken to some of my counterparts, they are using it for code like improvement and code like trying to find where the errors could be. So those same things you can also use for your world as well, where you can see like you've collected enough data around testing and whether you can build something which is your own intelligence when you use versus like, okay, like can you develop an intelligence to identify those patterns?
All right. Makes sense. I think Sandeep, right? So that's how you can move forward in there. All right. Yeah.
Machine learning, having 3 years of experience currently. I'm an ETL BI analyst with 7 years of engineering industry. How do I use knowledge to learn data science? How do I use this knowledge? And Rajesh, which knowledge Rajesh is talking about, I'm not sure.
So he's talking about the ETL knowledge, right? So I'm an ETL and BI analyst. So he's doing a lot of data visualization these days.
Already you're in that side of world where you're using data and where you are aware of data. And if you're doing it in banking and insurance, like I'm sure you're working with a team where people are already doing machine learning because most banks will have that. Like if you have got a proper ETL and BI in place, then there are always going to be data science. So start hanging around with that crowd, see what they are doing, kind of make the transition along with them.
Okay. So I think that answers you, right? So I mean, if you're doing only the reporting part, I think you can add ML to that part. It will certainly enhance your profile, and you'll be doing predictive modeling as well, right? So if that's where you want to grow, apart from just the visualization part, then that area can certainly be explored. Fair enough, Rajesh. Agree, right, Roopam?
Yes.
Fair enough. All right. So, okay, could it be possible to differentiate between AI, deep learning, IoT with small examples? Okay, I think I'll leave this to you, or probably how the industry takes it. I would
so
probably have my idea.
AI is not even a right term. This is the last question that I'll take.
Correct.
So AI is not even a proper term, because artificial intelligence, if you see, like it's used in a very casual and very, I would say, not in right way when we talk about industry, because intelligence is something like what you do on a daily basis. So you brush your teeth, you're capable of doing that, you're capable of possibly driving a car, you're also capable of reading a newspaper and learning what's happening, you're also capable of
Okay, probably we lost you once again. Okay, guys, can you hear me?
creating new things from scratch. So say scientists are coming up with new ideas. You're also an engineer who can build rockets and planes. AI, like intelligence, like the way AI should be defined is something, some artificial way of achieving all these human tasks that we do. At this point, what is happening is all these the machine learning, deep learning model are specialized in one area. They do that thing very fast, very accurately, but it does not make them that, like, if you ask a deep learning program that is like doing, say, image recognition to brush its teeth, it has got no idea what to do. So that is what differentiates human from the current state of AI. And so AI is a word which is like more of a marketing pitch rather than reality. At this point, at least in industry, I don't know about academia, but deep learning is something which is very real. So deep learning is where you've got like these image recognition, one engine you build. Then you look at text, something will read through a text and say it's what the person is trying to say in that text. So that's like a one skill which you have, but the same engine will not have other skills. So deep learning is very real, which is working in unstructured environment, unstructured data primarily, image, text, and such things. IoT, if you see, is just a way to generate data. So it's not something which is so IoT is like these sensors, where like the one of my described magnetometers, then there are sensors installed in cars to read how fast the car is going. So IoT again is a very different, it's just a way to generate data. It's not intelligence on its own.
So
So you'll
basically,
use
these are
ML and GL to generate intelligence.
sorry.
So these are three different completely different.
Yeah, so these are three different areas, is what you can say. Deep learning is one of the ways to achieve AI, and IoT is a very different field, right? So anything smart that you talk about today, we're generating data using sensors and then kind of then applying the learning on top of it to make it smart. So they've the connectivity comes from that, right? I think that's what you want to know. So AI is any kind of artificial intelligence, that will be AI, and deep learning is specific type of machine learning algorithms which help you do work on unstructured data, and IoT would be a different way where you're just collecting data through sensors. So I think that's how the differentiation should be, which is what Roopam also said. So pretty interesting session. I hope you kind of got a lot of insights from this. I really appreciate Roopam, your being here and taking out time for us, and helping a lot of people, and maybe setting the right path and making them very clear on how they can really get to the next level in their lives, right?
My pleasure.
Really appreciate that. So on that note, I think we'll be signing off. And if you have any questions, queries, you can always log into dimensionless.in. You can see ucanalytics.in .com, is it .com?
.com.
Yeah, so it is UNC all the letter UC and then analytics.com. That's a blog that Roopam writes. You can follow that blog. Again, a lot of interesting things there. And for any questions, queries regarding data science and AI, you can always visit dimensionless.in or reach out to us through various ways. I'm sure you keep getting our mailers, so you can always let us know. Fair enough, guys. Thank you so much for being here. Thank you so much, Roopam. All right. Yep. Bye bye. Take care, everyone.
Bye-bye.